Okay, we're talking about slope-intercept form. This should be nothing completely new because we kind of talked about it before. Slope-intercept form is written in the form y equals mx plus b, where y and x are your variables. That leaves m to be your slope and b to be your y-intercept. Imagine that, slope-intercept form. Wow, amazing. When we're talking about the slope is the rate of change i.e. the rise over run. So that's what you should have under the slope is. And I know my text doesn't fit exactly where I want it. The y-intercept is the point where the line crosses the x-axis. I'm sorry, not the x-axis, the y-axis. That's why it's the y-intercept. Okay, the point where the line crosses the y-axis. The formula for an equation of a, write it in, line using its slope and its y-intercept. If you feel like we're beating it over the bush, it is, but you have got to know what the y-intercept is and what the slope is and when to use what. So let's look at the steps for graphing. We've already learned how to graph something that's in slope-intercept form, so let's just remind ourselves what that is. We're going to start by placing a point at the y-intercept. So if my line is y equals negative 3x plus 2, let's go ahead and label that my m, or my slope, is that negative 3, and my y-intercept, b, is 2. So I take my y-intercept and I go up 2 on the y-axis and I put a point. From that point, you count out the slope to the next point. And it does say be careful about positive and negative directions. Okay, so this is negative 3. Negative 3 is the same as negative 3 over 1, or 3 over negative 1. So I can go up positive 3, left 1. That's what this one says. Or I can go down 3 over 1. That's what this says. Okay? So once I have my points drawn, and remember I need at least 3 of them to form a line, I'm going to connect my points. Okay? So I connect my points like such, and a good mathematician also labels their line. So I would label this y equals negative 3x plus 2. That is how we graph. This should not be super new to you. Put this to practice. We want to find the equation for a line is what it says here. So I'm going to look first for that y-intercept. And so I look at my y-axis and I see where it crosses. It crosses at negative 1. So I'm going to put that as my y-intercept. Then I want to look at the slope. It goes down 1 over 3 to this point. That's written like this, negative 1/3. Up here it goes up 1, left 3. So 1 over negative 3. Is this the same thing? Absolutely. So I'm going to write my slope as negative 1/3 x and fill that in. So my final equation is y equals negative 1/3 x minus 1. And that's what makes this line that line. Try this example, example 2, on your own. Okay, it says to graph each line. So in order to graph, I first look at my y-intercept. Here it is plus 4. That means I'm going up 1, 2, 3, 4 on my axis. Then it's negative x. That negative, it has an invisible 1. It's really like saying y equals negative 1x plus 4. You don't need to write that 1. It's an understood one. But it does exist. So remember, I go down 1 over 1. Down 1 over 1. And there's my line. My final step is to connect those dots and write the equation of a line. So I would write, well, they have it written here, but we can write it again. Y equals negative x plus 4. This one, notice it's not in slope-intercept form yet because the y is not by itself. So I come off to the side and I say, what the heck is going on? Well, to get y by itself, I just need to subtract 1 off both sides. Not too terribly hard. So now I have y equals 1/4 x minus 1. That is in slope-intercept form. So I can start at my y-intercept of negative 1, and then I go up 1 over 4, or down 1 left 4, which is also a positive thing to do. I connect my dots, and I label my line in y-intercept form, or slope-intercept, sorry. Okay, so just like that. Let's look at some of these extra work problems, or special cases in extra work. So, you'll see this one. Is it in slope-intercept form? Yes, it's y equals something x. Does it have that plus b? No, because that b is 0. That means that this case starts at the origin. This one, y equals 4. Is it already in slope-intercept form? Yes. It just doesn't have a slope. This is my y-intercept. It doesn't have a slope. It has no slope. What? Remember, this is the kind where I graph them. And here's my coordinate plane, and I go on my y-axis 1, 2, 3, 4. And for every x point, it will always be like this. And I draw my line and connect. I'm sorry, this is not a no slope. It doesn't have a slope because it is 0 slope. There is a 0 in front of the x. My mistake. 0x plus 4. Okay? This one requires some extra work, as they say, because is this in slope-intercept form? No, it's not. So to get it to be in slope-intercept form, I'm going to have to manipulate. Meaning, not only am I going to move that constant to the other side to get 3y equals 6x minus 5, then I also see that this y has a 3 by it, so I would divide each piece by 3. So my final equation would be y equals 2x minus 5/3. Okay? So you might have to manipulate some of these things down here to be in slope-intercept form, but I need you to find the slope and the y-intercept for each one. Okay? If you need to draw a graph, that's what's going to probably be easiest for C. Okay? This one gives you 2 points. Plot them on a graph, then look at the slope and the y-intercept. Okay? So you're not just finding the slope and y-intercept randomly. You're going to want to graph these, see what they look like, and from the graph determine the slope and y-intercept.